Okay, good afternoon to everyone. It's my pleasure today to introduce the Annamaria Mazzoni's talk on the topic optimizing water portfolios, strategies for sustainable groundwater management in hyper-arid environments. This webinar is one of the ways in which CMCC is celebrating World Water Day. It will take in, that will take on 22nd of March. This year, theme is glacier preservation, save our glaciers. Glaciers are critical to life. Their meltwater is essential for drinking water, agriculture, industry, clean energy production, and healthy ecosystems. Rapidly melting glaciers are causing uncertainty in water flow with profound impacts on people and on the planet. On the day itself, the UN World Water Development Report will be released, focusing on the same topic about the glacier preservation and recommending a policy direction to decision makers. But before starting the technical part, please allow me a few words about our institution, CMCC. This year, we celebrate the 20th anniversary of the center establishment. We are a leading research center focused on understanding interaction between climate change and society. We cover all the aspects related to climate change, from mitigation and greenhouse gas concentration up to the impacts on the different system and socio-economic consequences. So we cover all the aspects related to mitigation and adaptation. We move from the model to solution, advancing climate research through a multidisciplinary analysis, combining climate modeling, impact assessment, environmental economics, and supporting science-driven adaptation and mitigation action. We are trying to reconstruct and rebuilding our organization because we are growing a lot. And so now, 3 multidisciplinary research institutes were established more or less 2 years ago. There are 4 strategic programs on frontier topics. There are some centers supporting our work, and we have a facility completely devoted to the IHPC system for climate modeling. So, few words about our strategic programs. They are 4. They are related with the integration of the planetary biogeochemical and industrial carbon cycle, global coast as a new frontiers, predicting socio-economic impacts of climate change, integrating AI and machine learning in modeling. So, our centers about high-performance computing center, advanced digital innovation center, advanced training education. So they support the activity of CMCC, and in particular also the activity of our research institute. The 3 institutes cover different domains, but they work, of course, together, and their expertise, their knowledge are strictly linked. The Institute for Earth System Prediction, leveraging climate modeling capabilities, turning scientific knowledge and improving with predictive tools. Institute for Climate Resilience, working on different fields and different impacts for risk assessment, policy support tools for sustainable climate resilient development. European Institute for Economics and Environment, working on the final part, I will say, of the cascading modeling chain, but take into account also socio-economic consequences, but also the first step of the chain related to the greenhouse concentrations. So now let me move a personal moment from a new division in CMCC. A soil and water system division was launched officially in January 2025. I'm going to lead it in the February 2025. But what is the aim of the new division? The aim is to enhance the knowledge on the dynamic on the lower part of the Earth critical zone between the bedrock and the soil surface, including surface water and groundwater. So putting together the expertise, knowledge, improvement understanding about the soil-water nexus. We'll try to do it by using the different approach, physically based approach, but also AI and machine learning approach, and trying to create a sort of hybrid modeling chain. Also trying to going beyond the usual silos, for example, across different spatial scale from local to global and temporal scale from covering from sub-daily up to the multi-decadal time horizon. Of course, our activities are completely framed in the strategic programs of CMCC. For example, we'll work in the Global Coast as New Frontier, contributes to the development of innovative modeling chain, putting together inland waters with part of about the coast and marine waters. Or we support development of a new modeling chain in the framework of predicting the impact of climate change in terms of socio-economic consequences program, and so integrating components related to soil and water and participating in development of complex modeling chain. So we are really involved in track recording and publication. More or less, last year we published more than 200 publications, with more than half in the top 10% journal. And we release also reports for laymen, for public authorities, and for communities. And so, but now let's move again to the topic of the webinar. And so it is really important for the water resources, not by chance. It was also the topic of the Water Day 2022, where the label was Groundwater, making the invisible visible. Today, the moderator of the events will be Dr. Jenny Lawler, Senior Director of the Water Institute at Dublin City University. She also worked at the Qatar Environmental Energy Research Institute, where she had the opportunity of meet and collaborate with Annamaria. Her research focuses on the development of sustainable membrane and novel material-based separation processes for environmental application and public health protection, with particular interest in monitoring and remediating emerging contaminants. We hope that these events can also serve as an opportunity to initiate collaboration between CMCC and the research group. So before leaving to her the floor, a few rules about the interaction. Soon after the talk, a Q&A section will be moderated by using the Zoom tools. Your audio and video are deactivated by default. If you need to intervene or ask questions, write in Q&A section, and this part will be moderated, as said before, by Dr. Jenny Lawler. So I leave the floor to her. Thank you for your attention.
Thank you very much, Guido, for the very kind introduction and for the comprehensive introduction to CMCC and the new Soil and Water Systems Division. It's my absolute pleasure to introduce Dr. Annamaria Mazzoni. Annamaria is an environmental economics researcher with over 10 years of experience in international scientific institutions across the US, Qatar, and Italy. And she is currently a researcher in the newly formed Soil and Water Systems Division at the CMCC Foundation. Previously, Annamaria was a colleague of mine, working as a researcher and project manager at the Qatar Environment and Energy Research Institute, QERI, which is part of Qatar Foundation. And she previously held research positions at the University of Southern California and Caltech. Her vast expertise spans water resources management, the water-food energy nexus, non-conventional water resources, water footprint and trade, hydro-economic modelling, sustainable water management, and particularly focused on the Swana region. Her current research centres on groundwater sustainability in the critical earth zone, with a focus on arid and hyper-arid regions, integrating hydrological modelling, socio-economic analysis, and climate science. Annamaria holds a PhD in economics from the University of Turin and the Collegio Carlo Alberto, which she completed while working full-time in Qatar. She also holds an MA in economics and environmental policy from the University of Turin and a BA in political science and international studies from the University of Bologna. Annamaria, we're very much looking forward to your talk, and I would like to hand the floor over to you. And I will revert with questions from the audience at the end of your talk. Audience members, please write your questions in the Q&A. Thank you.
Thank you very much, Guido and Jenny. Let me share my presentation so that we can kickstart. Please confirm whether you can see it in full screen. Now should be working.
Yes.
Again, thank you. Thank you, Guido, for this opportunity and this responsibility on World Water Day. And thank you, Jenny, for your kind words and introduction. As mentioned already, I will be talking today about optimizing water portfolio strategies for sustainable groundwater management in hyper-arid environments. So, but first thing first, just a bit of context. What's groundwater? Groundwater is actually water that is stored underground from a few shallow meters below the surface, or even deep to hundreds of meters below the subsurface. And it's water that is stored not like in a bathtub, but is actually stored between soils, in pores, and in rock crevices. The body that contains this water is defined as an aquifer. So often aquifer systems are another way to call and define groundwaters, or at least the bodies that contains those water. And within the aquifer system, groundwater can move vertically and horizontally thanks to the permeability spaces of the construct. Groundwater, as highlighted also by Guido, is an integral part of the Earth's critical zone, and is a fundamental part for the water cycle, as it provides several services to ecosystems and streams, flows, and so on. Another characteristics of groundwater is that it can be renewable or non-renewable. Renewable is usually groundwater that is able to be replenished through percolation from the floor, from precipitation, and or other water bodies, and it can be therefore renewable, so recharged. Non-renewable is technically not very exact in the sense that virtually all the groundwater is renewable, but of course non-renewable groundwaters, or the so-called also fossil aquifer system, are the one which replenishment rate exceeds human scale time, because it's very, very much slow. So, but how much? So all this groundwater that is stored and is hidden from our view, because we are used to see reservoir surface water, how much is vital for our global water supply. So actually 99% of all liquid fresh water on Earth is groundwater. And groundwater also makes up to 70% of the water used for agricultural production, food crops, livestock, and so on. And 50% of the population uses groundwater for drinking supply, so for domestic supplies. Similarly, also groundwater sustain, as I mentioned, ecosystem, and actually 53% of groundwater depending ecosystem, GDEs, that exist on the Earth are actually in areas where there is a decline in the groundwater bodies and groundwater supply that is sustaining them. So again, the groundwater system, although we don't see them, they provide the nexus of essential services, from the provisioning services that are the one that we are most likely to know, like feeding human needs, basically, to regulatory services or supporting services that are needed for the habitat and ecosystem we live in. Another point is also that groundwater is also significant cultural values, because in many communities, especially local indigenous communities, is often regarded as a sacred heritage. And in this sense, their practices, their idea of groundwater can also be helpful in guiding us in strengthening our approach and our way of managing this resource. So a little bit of context again, because I will be talking about arid and hyper-arid zones, which are actually sub-zone of bigger categories that are the drylands, which actually are cover 41% of Earth's land surface and host around 2 billion people. You can see them distributed in this way, and I will be focusing on presenting you today case studies from arid and hyper-arid environments, so orange and red dots. And what are the characteristics of arid and hyper-arid zones? Actually, In these zones, there is a very low to minimal or almost negligible rainfall, high temperature, high evapotranspiration, and scattered to no vegetation almost, so which makes it very, very hard agricultural and human settlement, of course. And another main characteristics is also that the majority of these arid and hyper-arid zones depends on groundwater for their survival and for the survival of the human beings on them. So another thing, I mean, now we are approaching actually the area, the geographic area that will be today's area of study. And basically the SWANA region, so the Southwest Asia and North African region, and particularly the MENA region, so the Middle East and North Africa region, as you can see from the map, hosts among the biggest shared transboundary aquifer systems that are shared across either the Arabian Peninsula or North Africa. And also this area exemplifies very, very much the complex water challenges of hyper-arid environment, where, for example, groundwater is almost the solely source of water. Climate change, which is impacted to reduce precipitation and rainfall patterns, will also impact more severely these areas. At the same time, socio-economic drivers like growing demand for food, growing population, and therefore growing demand for water and food will also put further stress on already overexploited resources. Of course, this is also linked to water and food security. If there is a mismatch also with the water governance that in some cases is a bit weak, or is not really able to oversee and protect and preserve the resources, can also drive insecurity, food insecurity, and therefore also undermining stability in a regional and more geopolitical context, so to say. Another relevant information about this area is that, as you can see, the majority of the fossil aquifer system in the area are transboundary, meaning that they don't follow national borders or country border, and these further highlight the necessary for cooperation in the management of these resources. So again, if we are to consider groundwater resources, and we have to categorize somehow the challenges that they have to be confronting with, I would say that we can classify in three types of macro topic, along temporal, spatial, and governance related one. Of course, all these three challenges are interconnected together, and they kind of proceed reinforcing each other, meaning that managing something that is very much complex is not an easy task. For example, from a temporal perspective, as I was mentioning, because is very, very hard to understand, and the recharge dynamics and the temporal variability of groundwater system, also because they respond differently and potentially lagging, and so they have a delayed system response to any kind of perturbation from anthropogenic on climatic system, meaning that maybe what we extract in water today, we will see it on the water table, in modification in the water table, years, age from now. Similarly, also we have spatial challenges, especially in the monitoring part of groundwater resources. So it's very, very hard actually to quantify and really understand how much water is buried underground and how much this water is affected by anthropogenic and climatic stressor. As mentioned also earlier, governance government challenges complement this issue, also because oftentimes there is no dedicated management. So the groundwater management is integrated in surface water management, water management in general, and this doesn't help the fact that potentially these resources should be extra protected, extra conserved, and should have ad hoc regulation and frameworks. Furthermore, and this is also connected to the temporal and spatial challenges, there is often a weak enforcement on the over-abstraction and the rules for abstraction of groundwater resources, which makes everything even more complicated, as often this water is abstracted, but we don't know exactly how much is abstracted from the ground and how much is left from the ground, or how much exactly was there in the first place. So actually, how do we sustainably manage something that is invisible and something that we don't really see, and therefore we cannot, it is also so challenging to quantify and qualify in terms of water quality. So potentially advancement in a technological tool, but also integrated approaches are the way forward. And those should be based on enhancing data collection and integrating them with local and better integration of local and regional data sets, together with advanced sensors and remote sensing, to have a global and comprehensive groundwater assessment. At the same time, modeling-wise, dynamic socio-environmental models should be the way forward to try to couple and put together climatic drivers and anthropogenic drivers and see the flow as in how these are able to estimate the behavior and the responses of these water resources. Lastly, of course, governance policies shall be strengthened and also should be even more science-based, so even more based on the results provided by the two previous steps that I just highlighted. So all this makes the groundwater system very, very challenging, but also very interesting in my opinion. And since the beginning of my research experience, I try to, let's say, try to answer and try to provide some innovative view to deal with this challenge in groundwater management. So one of my first attempts, and you can see that is fairly old from the graphs illustrating the results, was during my master thesis over 10 years ago, where I was exploiting an agent-based model. I tried to somehow understand whether groundwater resources could be used as a backstop or a strategic resource to manage water shortages in the Middle East and Arabian Peninsula area. For doing so, I established a water budget with scenario modeling for 3 aquifer systems: the Nubian Sandstone aquifer system, the Northwestern Sahara aquifer system, and the Umm and Dammam aquifer system, which is in the Gulf, in the Arabian Peninsula. And basically, what comes out from the results is, of course, the depletion, a very, very sharp depletion of these groundwater, of these big water bodies, but also that in order to use groundwater and preserve it as much as we can, we need coordinated management and a diversification of the water portfolio away from this kind of resources, especially if we want to sustain them, their ecosystem, and therefore the human ecosystem in the long term. Fast forward for my PhD, I elaborated a more, let's say, not refined and sophisticated hydro-economic model, where I expanded the area and the assessment. So I tried to cover and model, so basically, and quantify water deficit and groundwater depletion for the main aquifer system within the MENA region, which are basically shared by all the countries that you see listed. I try to elaborate more both on the climate scenarios and also on the socio-economic scenarios that I link to the socio-economic, shared socio-economic pathways, SSPs. And even in this case, the results confirm basically that the majority of the groundwater resources will be depleted, especially in the Arabian Peninsula, which is also an area of the world where no other surface water resources are available for sustaining human needs and also ecosystem needs. At the same time, And the result shows that unfortunately, the countries that will face the biggest water deficits are also the countries that have less financial capability potentially to diversify their portfolio and actuate strategies that can ensure longer-term sustainability. As you can see from the implication sides, like Yemen, Egypt, and Libya. And this is in a context that is already heated for many reasons, does not certainly help the future. So now a fast forward for the last project that I worked on while I was working in Kiri in Qatar. Is a Belmont Forum project from the Coal Soils 2020 that was awarded and started in 2021. It just finished last December. And the project is called Interaction, which states for integrated assessment of climate impacts on ecosystem functions and productivity of critical zone ecohydrology. The overall aim and goal is to create a framework to address management issues on the water scarce critical zone system. Water scarce critical zone system are actually a subset system of the Earth critical zone that we described at the beginning of the seminar, where water resources are severely limited. So the approach that the approach that we have is like for this project is treating the water scarce critical zone as a socio-ecological system where we combine together science-based knowledge and stakeholder approach and stakeholder participation for design together water management policy options that are oriented towards sustainability, especially of groundwater resources. In fact, groundwater resources are the main resources under study within the 3 pilot, and the 3 pilot are scattered between Italy, US and Qatar, and those listed are the partner. I will be, of course, talking today about Qatar case study. But before stepping into that, let me show you a bit the architecture of the project. Basically, we designed the project for it to have a modeling loop and a stakeholder loop that communicates together. And our idea is like basically in the WUPI1 to collect all the data to better understand climate and anthropogenic drivers on the water resources that we have selected in our pilot studies. WUPI2 collect all the information that we can retrieve at expert judgment and aspirational management option from the stakeholder who participated in our project. WUPI3 is the data integration and system dynamic modeling, which is actually the approach and tool that we're using to put all this information into a system. And then WUPI4 kind of collect all the information from WUPI3 and kind of put them together in a policy recommendation that are relevant for the stakeholders and the decision makers. So why the Qatar case study is ideal and is extremely relevant? First of all, it's a bit different from the other 2 case studies in the sense that in the other 2 case studies, we selected regional and very local case studies. So for the US is the Consumnes Basin, while for Italy is the Torre Guaceto study in Puglia region, while for Qatar, we picked the entire country. There are several reasons for this, main being also because Qatar is as big as a region of Italy, more or less. Population-wise, potentially is quite small, as you can see. There are only around 2.6 million people in Doha, but at the same time, Qatar is a great example and somehow a living lab for exploiting and testing different management scenarios. First of all, it solely depends on groundwater as a freshwater source. At the same time, it has the financial capability of diversifying already its water portfolio, as it's also based, I mean, water supplies of Qatar is also based on TSC and desalination. And at the same time, it's particularly interesting because after the embargo that happened in 2017, there was also a boost in the agricultural production. The boost on agricultural production in a country that already sustained its agriculture on a non-renewable groundwater is a big challenge, and it had challenges on top, especially because the new strategies for food security, so for food production, are very much interesting and are very much increasing the pressure on the water resources. So all this together is kind of a great example on how we can do to better manage these resources. So how did we put all the systems all together? We exploited system dynamic modeling. System dynamic modeling, we choose it because it really helps to reduce and simplify complex dynamics. And also because in our case, we use it to predict water system and how the water system will behave in the future under different scenarios and by changing few parameters of the systems. The system dynamic modeling works with stock and flows. In our case, the stocks are the quantity of water that is available in Qatar at a specific moment when we start our simulation, and the flows is like how the water changes according to different scenarios and according to different drivers and uses. And so two main important and relevant component of system dynamic modeling that helps both policy making and decision maker, and also helps identify and guiding and estimate and interpreting all the variable are the performance indexes that we have included in the model. In our case, there is we have included a water sustainability index that measures the system's ability to sustain water supply under different conditions, and also we have included a reliability index that indicates the likelihood that a system, in our case the water system of Qatar, can meet water demand without shortages over time. Why we have included these performance indexes? Just to help decision maker to better interpret and analyze the outcome from the scenario that we have provided. Likewise, what's on the right-hand side is the causal loop diagram that is like a structure that is typical of system dynamic modeling that also basically explain how different drivers positively or negatively affect water flows in Qatar. I mean, in Qatar in our case, but it can be applicable to any context in the world. So so this is more or less how everything was structured. So basically, on the left-hand side, we have the Qatar water sector, so the water demand categories, how they were split in the model, and then the water supply and the losses of the system. So you can see that the majority of the water is split between domestic, industrial, commercial, government, and agricultural water demand, from which groundwater makes up for the most. And then water supply is provided by groundwater, TSC, and desalinated water. Then we combined all together water supply and water demand in several scenarios, and we specifically did and we designed the scenarios accordingly to a combination of different water increase or decrease. And availability. Sorry, there's the cat that is coming from time to time. And we also tested, like building upon the first scenario matrix, also groundwater scenario matrices and groundwater availability in the future. And those the scenarios for groundwater were tested over some more tailored and specific assumption on groundwater. But more or less everything is based on how should we combine what increase in consumption and enhancement in production of water in order to balance and sustainably manage Qatar's water resources. Now to some results. So the scenarios were clustered in 9 clusters in order for them to be more presentable for policymaker. And we can see that if we look, as I mentioned, by the performance indexes, we see that the policy scenario A, which is the one related to the business as usual, have at 32 years without of the WSC, so the system is quite the resiliency. The system's resilience is of 32 years. Similarly, there are other policy scenarios that can be helpful and can be picked and choose potentially by policymakers. Much less preferred, the least preferred option are the policy option F, which and the policy option D. And if we look instead, I haven't showed them here, but there are in a paper that I cite. If we look at the sustainability of groundwater properly, the sustainability is there is a scenario, the R8, that grants sustainability of the groundwater resources up to 40 years, but some scenario also exhibit unsustainability for the majority of the part for what concern groundwater resources. So altogether, all these results packed together to say what? That first of all, that we can see that from a very simple model up to a more complicated model like this SDM that we have worked on together with the rest of the team in Qatar. Groundwater is very much at risk, and it's over abstracted. And in doing so, what we can suggest in terms of policy recommendation, for sure, limit groundwater use, and in doing so, limiting also not just promoting sustainable irrigation technique, but really diversify the type of water that is used for irrigation or for any other use, really limiting it and controlling that the limit that is fixed for groundwater is respected. At the same time, and this is particularly interesting for Qatar, but maybe also can be exported in other contexts. Water infrastructure development is required, and so keep investing in TSC, produced water, and desalination, potentially solar desalination. So I mean, we kind of go to the net zero option, and we don't continue emitting while producing water that we need for survival is also a way to go. Strategic reserves and the long-term water strategic plan are core for Qatar, but also for other region other contexts within the region, potentially also the Mediterranean area, and the North Mediterranean area as well. And of course, something that comes from the data collection when one start to populate the data to run the model. For sure, something that one notices is the lack of data and the lack of consistent data and for the collection and for them to be put together and run the model, but also the lack of data is reflected in terms of policy making, in the sense that the enforcement and control of actual groundwater reviews on point, not just for monitoring the quality and the quantity, but also to check how much water is actually used, should be performance, should be advised and enhanced in many areas. So what are the overall key takeaways of managing groundwater and water resources in general, but specifically groundwater, is that we need an integrated, participatory and adaptive approach. So we have to also include very much stakeholders and decision makers in the water realm since the beginning, potentially. And we don't have to provide them only with data, but we really should be careful and manage both their expectation, but also what are the aim and the targets or the policies that they would like to realize and to enforce. Now that the seminar is coming to an end, today is, as Guido mentioned, I mean, in 2 days will be World Water Day 2025. And I mean, of course, it's glacier preservation, and one may ask what's the real deal with groundwater, because my talk was mainly about that. So I have tried here to identify what are the common challenges between groundwater and glaciers, in terms of climate change, but also long-term impacts, delays, but also the transboundary governance issue, which are in common with both of them. Both kind of resources are critical for ecosystem and for the water security of many nations, and both of them are quite difficult to monitor and quantify. Of course, as opposition, groundwater has a slow recharge and glaciers has a slow melting process, but like both together form the water cycle and need to be preserved and protected. So thank you very much for your attention. Any question or can be provided now and or via email later. And I would like to thank you, especially also the group that in Qatar with whom I worked for the Belmont Forum project. So Sarah, Naim, Iman, and Dr. Adel, who we are still in contact with. And so thank you very much for listening.
Thank you so much, Annamaria, for a really, really interesting presentation. I'd like to invite the audience to please go to the Q&A section where you can type your questions into the chat box there. However, I would like to open the floor with some questions to you, Annamaria, if that's okay. I was very interested to hear about your modeling technique. And I was wondering, just in terms of validating the results of the system dynamics models for this context, you know, historical data may not always be available or comprehensive or accurate. So I'm wondering, what's your approach to validation of the model in this case?
Just a second, let me go with, because the cat wants to ask, just a second, because otherwise it will bother us. Just a second. Sorry. So the entire process of validation, I mean, historical data are not easy. So what we've tried is really to assess and validate the sensitiveness on the model. I mean, in the paper, there is an entire section of validation because, as you rightfully mentioned, especially for what concerns the data collection of the stocks is not easy neither to retrieve nor to populate, as there are a lot of data gaps. So we underwent a lot of validation of the model itself, how it performs and how the data performs. And there is an entire section dedicated on the paper about that. For sure, further validation should be required in terms of availability, I mean, water availability, especially because for Qatar, I mean, you've been there, so you know exactly like how much water is there, and is it really the actual amount. That is like it's also a matter of trust. But like with our validation, we could see that I mean that the model performed fairly well in replicating and simulating the behavior. Although was the starting data were a bit of a mess to populate, and also we had to fill the gaps. Also with some literature also as well, that we use a paper from the literature to populate the data gaps at the beginning. And of course, there were assumptions that we were to make to simulate the behavior in the future because of data constraints and availability.
Yeah, it's very challenging. I will bring you to a question from the audience, Annamaria, please, from Tapash Mazumdar, who asks, what are the other models available other than SDM, especially when data is scarce?
Well, that's a tricky question. I don't think that, I think that for my personal experience, system dynamic modeling is a great way, because it models, and you don't need a huge amount of data necessarily to make it work. I think that other solution could be, I don't know, putting together hydrological model that allows you to have more data, but it also depends on what would you like, what's your target? Do you want to simulate policies and management scenarios? Do you really want to know just the stock and flows? So it's a question that should be dependent on not exclusively on the data availability, but like on what do you want to do with the data that you have, or better, which kind of answer and research question you have, and based upon that you can tailor and pick which model is more appropriate. I mean, we don't necessarily need to have a lot of data, but it really very much depends, in my opinion, on what you want to do with those.
Mm-hmm. And Tapash has followed up with specifically on the policy recommendation for the water uses, which I think you've answered. We have another question from the audience, from Gloria Mozzi, who asks, based on the previous question, can SDM models simulate also different behaviors of the users, like ABMs?
Yeah, I think so, because you can populate with any behavior. So you can basically consider that the behavior or the preferred choice or the preferred policy of a specific water user or water manager, and you can include it in the model and run it and see. Based upon that use, I mean, it becomes basically an extra parameter that you can plug in the model, and then based upon that, you can see how your flow of water performs, having added one specific rule or extra use from an extra source, or like plugging in another part. For example, like do you want to know how tourism, which is an extra aspect that can be taken into account, that can be also plugged in and isolated compared to other, I mean, similarly to other parameters.
Thank you, Annamaria. I have another question, if you don't mind. Like hyper-arid environments will often have very extreme variability. So do you have a way to account for short-term extreme events, like flash floods, and their impact on groundwater in your models?
Okay, not in this one, but I'm glad that you've asked this because this is actually what we are trying to be working at the new division also with Guido. A spin-off of the Belmont, not a spin-off, a part of the research that was carried with the with the Belmont Forum project was also investigating how flash floods, which are typically of Qatar and arid environment, can be actually used to identify potential groundwater recharge areas and zones. So there is a paper that came out for this, and but for those we didn't use this system. Conversely, we use like more hydrological modeling and traditional system as well, while including how the system overall can respond to flash flood and the kind of extremes which are typical and are going to be exacerbated by climate change. Is also a research question that Guido and I and the other colleagues and so on us are trying to understand and like put in the next stuff to do in the pipeline, basically. Because yes, it's like it's pretty fascinating also the behavior and how extreme events are linked to climate change, but also at the same time how groundwater resources responds to these extreme events and how they can be effectively managed even because of that.
Thanks, Annamaria. So at the moment, there's no other questions from the audience. So if you don't mind, I'll ask you another question.
Yeah, sure.
I'm just wondering, like, are there any kind of new technologies or innovations like satellite data or AI that have helped to improve the accuracy or the efficiency of this type of systems dynamic modeling in groundwater management?
Okay. The problem, the big problem, in my opinion, is that for sure I mean, I mean, I consider, other than the actual new innovation, in the sense that, of course, satellites and radar technique can really very much help groundwater assessment. The question is always, I believe, and of course, like there are constant innovation in that field. On the other hand, I think that considering that kind of innovation for monitoring and assessment, one should always be mindful of the trade-off that there is in terms of how much deep you can go, because in the ground to actually know. So potentially it's very, very much good for shallow aquifer resources. Conversely, is much harder for, I mean, the deeper groundwater resources you have. Likewise, the resolution of the satellite's images sometimes doesn't fit the pilot that you are studying, especially if you are studying smaller patches. So there is always a trade-off of quality of the output that you get and what I've been using in terms of spatial resolution at large and vertical profiling of the groundwater resources. Another thing to take into account is also that, again, going to your first question, for validation, you will still need eventually drilling and having punctual measurements. Which of course they are spatially scattered and data. So that's then I don't know how much more to add, because that is not my direct domain, to be honest. I'm more on the but yeah, this is my 2 cents on the question, actually.
Okay, no, that's really interesting. Can I ask you one final question?
Yes,
if
sure.
you don't mind, Annamaria?
No, absolutely.
I'm just wondering, like, in terms of the kind of resilience of the model itself, I know you've touched on integrating other hydrologic and climate change models into the SCM, you know, to kind of be able to consider climate change impact on your predictions and that kind of thing. But are you able to include resilience of the model itself for changes in human behavior? So changes in agricultural practices, changes in water consumption patterns, and other things that might significantly impact on groundwater systems?
Yeah, I think that can be included. I mean, in this specific, I mean, the result that I've shown, actually, the agricultural modification patterns were not fully integrated in this specific one, but they are crucial, especially in a place like Qatar. I did other work on measuring how water management, irrigation practices affect water management. Not with the system dynamic modeling, but I used the means of water footprint to translate food strategies, and I did it for Qatar. I translated basically food strategies and policies that were put in place after the embargo for the future of the self-sufficiency of the country into water endowment. So, and asking myself, okay, how much water will be needed for meeting these strategies? And if this water, and again, is taken mainly from groundwater, how much this groundwater will be depleted. So I didn't use a system dynamic modeling, but I put together with the water footprint approach, but I try to combine these two together as well. But that's a separate research that was not shown today. But definitely it can be implemented either ways in many different, and is extremely relevant to include that part as well, certainly. Yeah.
Fantastic. Thank you so much, Annamaria. It's been a really nice insight into how you're bringing together the different parts of your research. And obviously this is going to be very, very relevant as parts of the EU become more arid, unfortunately, into the future under our climate change projections. So I'd like to thank you very much. I'd like to thank the participants as well for their very insightful questions. And I'd like to hand over to Guido to close the webinar. Thank you.
Okay. Thank you, Annamaria. Thank you, Jenny, for moderating and taking this webinar. Really interesting. Thank you for a good way to celebrate the World Water Day. I would like to invite to next events that you can check by using CMCC social channels. Thank you. Have a nice day.
Thank you very much to everyone. Bye-bye. Ciao.